Hey folks. All right, this is the second to last video. That means this is like the second to last time you're going to see me jam out before talking about CHEM. Okay, so as you can tell by the slide, we're getting into more on this UV Viz. Hopefully this is still familiar to you all from instrumental. I was distracting myself with the music. I had to stop it. I was going to do something cool where I talk through the music, but I was getting distracted. Okay, so here we go. So I think a lot of this stuff should be familiar to you all, particularly for those of you that took instrumental analysis. But all the same, we're going to go through it. Okay, so these are our fates of electronically excited states. And so as you can tell, there's a lot of things that can happen. So let's just talk about them one by one. So we've got stimulated absorption. And so that's exactly what it sounds like. Transition from a low energy state to a high energy state. And so absorption is proportional to the intensity of stimulation. And as we've talked ad nauseum, that's related to the transition dipole moment operator. Okay. So then we have stimulated emission. And so that's transition from a high energy state to a low energy state at the same frequency as absorption. Okay. So emission is proportional to absorption. All right. And so these two things right here are often what create either absorption spectroscopy or emission spectroscopy, most notably in elemental composition analysis, right? Doing flame AA, for example. Okay. So we have spontaneous emission. And so that's the transition from a high energy state to a low energy state at a different frequency as the absorption. Okay. And so as you might guess, spontaneous emission can be classified as either fluorescence or phosphorescence. Okay, and we'll talk about that momentarily. So there's intersystems crossing. So that's a non-radiative transition between states of different multiplicity. Okay, so non-radiative means that it's transitioning to a different energy state without the release of any light. Okay, and so oftentimes that transition between these two states of different multiplicity is occurring where the states have good overlap, okay, and also where they have very similar energy. And it's important to note that because this is different multiplicity, this is pretty rare for intersystems crossing, okay? And so when things are pretty rare, they can be kinetically slow, okay, as we'll discuss. So internal conversion is a non-radiative transition between states of the same multiplicity. So this is more common than intersystem crossing because the multiplicity is conserved. Okay, so now our two spontaneous emissions can be classified as fluorescence or phosphorescence. So fluorescence is stimulated absorption followed by spontaneous emission at a lower frequency than the absorbing frequency. Okay, so in other words, the light that is emitted in fluorescence is at a lower energy than the light used for absorbance. Okay, and so multiplicity is conserved. So we only do triplets to triplets or singlets to singlets, and the fluorescence lifetime is very fast. So that means the excited state decays really quickly. Okay. Phosphorescence is spontaneous emission at a lower frequency, similar. Okay. However, multiplicity is not conserved. So this is where we get a triplet to singlet or singlet to triplet. And because of this, lifetimes are very slow, as this is a forbidden process, right? Just as we talked about with intersystems crossing, okay? And so what we start to see in molecules, oftentimes forbidden processes in molecules can be observed, albeit at very low intensities or very slow rates. And the reason why these forbidden transitions can be observed in molecules and not atoms is because molecules can rotate and vibrate and contort themselves in a way that might allow angular momentum to be conserved. Atoms can't do that, right? An atom has a very rigid shape and structure. Molecules, on the other hand, are kind of floppy, right? And they can be distorted and perturbed in a way that allows these forbidden processes to occur.